Hello and welcome to Forbest Academy, and welcome back to our AMC 10-12 preparation videos for the 2021 contest. This week we're going to be looking at 5 AMC 12 past paper questions and going through the concepts required to answer those questions. Today we are going to be looking at circles, and in particular the circle theorems involving angles inside of a circle. So before we start this question, we're actually going to go through all of the rules that we should know regarding circles. So our first rule, we're going to take 2 points in our circle. We're going to call them A and B. So we've picked 2 points on our circumference, and we're going to subtend an angle at the circumference and also at the center of our circle. And our circle theorem here is the angle subtended at the circumference is always half the angle subtended at the diameter. Or the other way around, the angle at the diameter is always twice the angle at the circumference. For our second circle theorem, we're going to again take 2 points on the circumference, A and B. And we're going to again subtend an angle on the circumference. I'm going to call that angle angle B. And then from those same 2 points, so from the same segment, we're going to create another angle on the circumference. And that angle there will always be the same as that angle there. So 2 angles on the circumference from the same segment will always be equal. Our third circle theorem, we're going to draw in the circumference of our circle, so that's going through the center. And we're again going to create an angle on the circumference. And that angle we've created is a right angle. And so our circle theorem there is any angle on the circumference in a semicircle will always be a right angle. And another rule we're going to be looking at is involving quadrilaterals that have been inscribed in a circle. That is, all of our corners, all the vertices of our quadrilateral are on the circumference, often known as a cyclical quadrilateral. And our rule for this regards our opposite angles. Diagonally opposite angles in a cyclical quadrilateral will always add up to 180 degrees. And that will be the same for these 2 opposite angles here, C and D. They would also add up to 180 degrees. We have 4 more rules to look at as well. So let's start those rules. So our first one is if I draw a chord onto my circle, and then I draw a line from the center of my circle bisecting that chord, that will always form a perpendicular bisector. So if we bisect our chord from the center of our circle, it will always be a perpendicular bisector. Similarly, if I draw a tangent to my circle, that is a line that touches the circumference of the circle just once, that will always form a right angle from the center of our circle. So the radius of a circle and the tangent at that point will always form a right angle. When we have 2 tangents to a circle that then meets later on, the distance, I've not drawn that second tangent very well, I'll just draw that one again. The distance between where they touch the circle and where they intersect will be the same. So a tangent from a point will always have equal length to where they touch the circle. And our final rule is called alternate segment theorem. And that is when we have a tangent to a circle, the angles it forms with two chords from that point will be alternate angles inside the triangle. So those are our rules that we need to learn. Let's apply it to this question then. A quadrilateral ABCD is inscribed in a circle with angle BAC equals 70, angle ADB equal 40, AD being 4 and BC being 6. So the first thing we want to do for a question like this is to draw it. It's very difficult to imagine these things, so it's always best to draw out these diagrams. And we don't know exactly what this quadrilateral is going to look like, but we can just draw in a bit of a shape, and if it's not exactly what it looks like, that doesn't matter too much. And we're going to label our sides A, B, C, D. We always go clockwise around a shape. And then we're going to mark in the angles and the sides that we know. So we know that AD is equal to 4, and we know that BC is equal to 6. We've been told that BAC is equal to 70, so that's from B to A to C, so that's drawing in a diagonal, and this angle here is 70 degrees. And we've also been told that ADB is equal to 40, so that is our other diagonal. That angle there is equal to 40 degrees. So we can tell straight away that this isn't an accurate drawing from us, but that is not something that should bother us right now. Okay, so first thing we need to do is we need to look at this and see what else can we fill in using those circle theorems that we've just looked at. And the one that I'm spotting straight away is that from B to A, we formed angle D, which is another point on that circumference. So from the segment AB, we formed the angle 40 degrees, which means the angle BCA must also be 40 degrees. In the same way, we could do the same with our 70-degree angle. If we know that BAC is 70 degrees, then BDC must also be 70 degrees. So we can cancel those off there. Okay, so what else can we work out? Well, we've formed a couple of triangles now, so we can also fill in some angles there. So we've got triangle BAC, and we've got two of our angles inside of it. So 70, 40, our last angle there, ABC must equal 70 degrees. Now we're trying to work out side AC. There's a couple of ways we can do this. The first one is just by looking at our triangle here. Looking at our triangle BAC, we can tell we've got two angles of 70 degrees, so therefore this must be an isosceles triangle. Not very well drawn, obviously, but if that's 70 and that's 70, then these two sides here and here must be equal, so AC must be 6. But let's look at an example and say that what would happen if that wasn't 70 degrees there? What would happen if this wasn't an isosceles triangle? Or what happens if we just didn't spot that that was an isosceles triangle? The other rule we can use here is our sine rule, because we've got in this triangle here, we've got an opposite pair of angle and side. If we use our sine rule here to work out AC, we can write that 6 over sine 70 is equal to AC over the angle ABC, in this case, sine 70 again. Multiply both sides by sine 70. Now, in this case, obviously, the sine 70s are going to cancel, but if that angle wasn't 70 degrees, we could have also worked out this question this way. So AC is equal to 6. Thank you very much for watching this video. Please tune in again tomorrow for more of our AMC 12 question breakdowns, and please like and subscribe this channel. Thank you for watching, and I'll see you tomorrow.